Now let's discuss about a very important part of this chapter, that is defining and understanding what is an event, or you can say occurrence of an event. See, event is basically an outcome of a random experiment. The formal definition is going to be something like this. Okay, you roll a die, or say you toss a coin, you pick a ball, or you're going to pick a card from a deck of well shuffled cards. See, and these are all the experiments. The outcome of an experiment is basically an event. That means, say you do an experiment of tossing a coin. Say you toss a coin twice. When you toss a coin twice, you're going to have head and head, head and tail, tail and head, or tail and tail, correct? Isn't it? So, the experiment is what? Experiment is tossing of a coin, or you can say tossing of a coin two times. Now, remember, this is the experiment. What is the outcome of the experiment, or what are the outcomes of the experiment? Those are these four things, correct? So, these are what we call as events. Generally, event is given by set E. So, set E is head, 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 tail, so on and so forth, whatever you have. Okay, so sample space is the collection of all the events. Or in other words, sample space is the collection of all the outcomes of the experiment. That's why if you look at it in the previous one, in the examples what we did, we wrote down everything, correct? There was no one specific type of a condition that was not there. So an event can be divided into many types and many categories, or you can say whatever you want. Okay. Now, based on what it is, we have given a particular name for it. Alright, so let's start and we'll understand different types of events. The first type of an event, we call this as an impossible event. Impossible event. Now, I would say that looking at this only, you can clearly tell what is an impossible event. That this particular event can never ever occur. Simple example, sun rising from west. Is it possible? Anywhere, any part of the globe, anywhere you go, I can never say that, oh, sun is rising from the west. No, never. Impossible. See, that's an impossible event, isn't it? Or say you roll a die. So in a die, you know that the numbers are what? Sample space is going to be 1, 2, 3, 4, 5, and 6. So I will tell, in a 6-sided die, numbered from 1 to 6, I want to get number 10. Is it possible? Nope. That is an impossible event. Okay. The next type of an event is going to be a sure event. See, a sure event is where it is definitely going to happen. Like the sun rising from west is impossible, sun rising from east, it's a sure event, isn't it? So, whenever you are going to have these kind of sure events, we are saying that it will happen and it must happen, it will happen. That's basically a sure event. Understood? So, this is one. The next type of an event, we call it as a simple event. See, simple event, the outcome, whatever you are going to get, based on the outcome, we are going to call it as a simple event. So, you are going to have only one event, or you can say one experiment, out of which you are going to have one event. That is a simple event. For example, rolling of a die, it's a simple event. Because you are going to take one experiment, just roll the die, 1 or 2 or 3 till 6. Or say you are going to toss a coin once. See, if you toss a coin once, see, for this one we can say a rolling of a die. This is a beautiful example. Or here you can also say tossing of a coin. But when I say tossing of a coin, let me be very specific. Tossing of a coin once. How many possibilities? Head or a tail? 50-50 chance, isn't it? See, very simple event. So these events are what we call as simple events. Okay, the next type of an event, this is a compound event. See, compound event is where multiple simple events are together and one event depends on the other. I mean, not all the time, but in some cases. Okay, but you have multiple simple events together. That is basically a compound event. Okay, for example, let's take everyday life example. All right, if you have to cross the road, first it depends on whether the vehicle is coming or not, isn't it? And or you can also say that if you have to cross the road, there has to be a red signal for the vehicle and green for the walking part. See, you crossing the road depends on whether the vehicle is going to be there on the road or not, isn't it? So these are what we call as compound events. Now, most of the things what you see in our everyday life is a compound event because everything is dependent on one another, correct? Or you can also say, I toss a coin. Once you toss a coin, I'm going to choose bat or fielding. It's a compound event because you choosing to bat or you choosing to field, that's an event. That event depends on whether you're going to win or lose the toss. Compound event. So in compound event, what we have is one event is going to be connected to another one. Okay, so what we have is combination of simple events or simple events together is called a compound event. Understood? It's a compound event. The next type of an event, we call it as complementary event. Complementary event. See, complementary is something where the set should not have, but the sample space should have. In the sense, let's say I'm going to toss a coin, say twice. Okay, just now we did it. No, in this video. If you toss a coin twice, you're going to have the sample space as HH, HT, TH, and TT, correct? Four possibilities. Let's say my event, whatever that event I'm defining, needs to have, let's say, at least one head. Okay, at least one head. That means I can have one head or I can have two heads, correct? See, if we are looking at least one head, my event is going to be HH, HT, or TH, correct? Now, complement of this event E is something that is the complement of the event is something which is there in the sample space but not in the event. Okay, so look at this one. Event is HH, HT, TH. Which part, or you can say which element, is there in the sample space but not in the event? That's TT. That means E complement, E dash is going to be TT. Understood? So, complement of an event is that set of elements which is present in the sample space but not in the event. So, those are what we call as complement of an event. Clear? It's a complement. Now we'll look into the next type of an event. See this one, let's call it as OR condition of events. Okay, OR condition. So when we say OR condition, that is A or B. Say we have set A which has head and tail only once. Only once. Say we have set B which is 1, 2, 3. Okay, now when we say A or B, what we do, we take both of them together and we are going to combine them. In the sense, when we say A or B, that is A union B. So OR stands for union. Okay, so A or B becomes H comma 1, head and 1. Okay, or H comma 2, H comma 3, or T comma 1, T comma 2 and T comma 3. See, we are going to have every element, isn't it? Every element which is there in set A, every element which is there in set B. So we are going to take all of them together. This is what we call as union of sets or condition. Clear? You have learned this in sets, isn't it? Same thing. Now the next one is going to be AND condition. AND condition for two or more sets. See, AND condition is nothing but something which is common for both. Common element. Okay, so whenever we say common, don't you think we need to do intersection? So here what do we do? Let's say we have A. Say A we have 2, 4, 6, 8. And say B is 1, 2, 3, 4. Now when you do A intersection B, that is common element for both A and B. What are the common elements for both A and B here? So 2 is there, 4 is there. Correct? So we can say 2, 4. This is AND condition. Very, very simple. Alright, the next one is going to be, we can call it as a one-sided set. I mean, it's not an actual name, but I'm saying so that you guys can remember easily. One-sided set. Or you can say one-sided condition. See, one-sided condition is what? Something which should be there in one set, but it should not be there on the other. Okay, for example, if I take this condition itself, okay, this one itself, look at set A and set B. What elements are there in A which are not in B? Let's mark it down. Elements which are there in A but not in B are 6 and 8, correct? Isn't it? So we write this one-sided condition to be A minus B. A minus B in the sense what? Elements which are there in A but not in B. So mathematically we can call it as A intersection B complement. So what is this set in our condition? A minus B is going to be 6, 8. Don't you think B minus A is different from A minus B? Because when you do B minus A, what do you get? You are going to get 1 and 3. Isn't it? So it's a very important part, that is A minus B is not the same as B minus A. Clear? Very, very important. Okay, let's do the next type of event. The next two what you're going to learn are very, very, very important. Okay, so since it is very, very important, so what I'll do, I'll put a star for this one. Very important. This one is what we call as mutually exclusive event. Mutually exclusive events. Now, the definition of mutually exclusive where the intersection is a null set. Okay, this is how it's going to be. That is A intersection B is going to be 5. Null set. This is mutually exclusive. But obviously we can't just stop it here, correct? Let's try to understand. Let's say you are going to roll a die. When you roll a die, right, let's write down the sample space. 1, 2, 3, 4, 5, 6. Now, when you roll a die, say you got number 3, let's assume. Now, when you have 3, that is my event is going to be 3. Correct? Now, when 3 is appearing on the die, can we get any other number? Is it possible? Never. Correct? Say my event A is going to be getting a number 3 on the die. And say my event B is getting a number 5 on the die. Is it possible that both of them can occur together? Can I ever say that when I roll a die, a single die, I'm getting 3 and 5 together? Is it possible? Never. Correct? That means if I'm getting 3, I can never get 5. Or if I'm getting 5, I can never get 3. That means one event which is occurring, it is going to stop another event from occurring. Correct? Like when you toss a coin, you can either get a head or a tail. If head is coming, then tail can never occur. Or if tail is coming, then head can never occur. So one event stops the other event from happening, correct? These are called as mutually exclusive events. That is, one event is going to stop from the other event to occur. That's why intersection is a null set. So mathematical definition of a mutually exclusive event is this. A intersection B is going to be 5. Understood? What are mutually exclusive events? Fine. The next one is also very important. That's why I'm going to put one more star here. This one is exhaustive events. See, exhaustive events are something which is going to stop after a period of time. See, exhaustive, it's going to exhaust after a period of time. That is, after a period of certain events and experiments, it is going to stop. Okay, these are called as exhaustive events. Now, the good thing about exhaustive events is every event you are going to take, say you have E1, you have E2, you have E3, so on and so forth till En, assume. If I'm going to take the union of all these events, this is going to give us the sample space because it has everything. Okay, let's take an example. Say rolling of a die itself. When you roll a die, I'll take two events. My first event is going to be all the odd numbers in the die. What are the odd numbers in the die? 1, 3 and 5. Say E2 is going to be all the even numbers, which is 2, 4, 6. Now both of them are exhaustive events. Why? Because when you take E1 union E2, what do you get? Don't you think you're going to get sample space? That's 1, 2, 3, 4, 5, 6. Correct? So these are exhaustive events. Now the mathematical definition of exhaustive event is nothing but this one. That is, exhaustive events are those when you take all of them together, that should give us the sample space. Alright? So these are different types of events. Just to quickly go through whatever we have learned. We learned about impossible and sure events, which can never happen, which will always happen. Then we learned about simple and compound events. Correct? Compound events, multiple simple events. That's all. Then we looked into and or condition. Correct? So and condition is where intersection, that is common. Or condition is where you're going to take everything together. Then we have complement of a set. That is things which are there in one set, which is not there in the other set. Then we have mutually exclusive and exhaustive event. Correct? Mutually exclusive, just now we discussed. One event stops the other. And exhaustive is where it is going to stop, it is going to end. And collection of all of it is going to give us sample space. So these are the types of events. Now in the next video, we'll solve few problems on the given definitions and conditions, whatever we have learned.